Hi, I'm Dr. Papia Bhattacharjee. In this problem, we have to evaluate this indefinite integral, natural log of x over 3. And we have to evaluate it two different ways. First, we have to use the integration table in Appendix C. And then second, we have to solve this problem using integration by parts. Now, if you look in Appendix C and try to find a formula that looks like this particular function, you have to look for evaluating natural log function. And you notice that formula 41 tells you how to integrate natural log of u du. And here is the formula. So we can apply that formula to solve this problem in part A. Okay, so our function is ln of x over 3 dx that you have to integrate. So look at the formula. You need that particular function to look like natural log of u, just one variable. So how will you do that? Just say this x over 3 is your u, right? So let's do that. U is x over 3. And then see, we are rewriting this in terms of a new variable u. So what should we do with dx? That should be rewritten also as du. So you have to evaluate du from here. So take the derivative in the right hand side. It's just 1/3 dx. Okay. So this is going to be natural log of u. And then how do we rewrite dx? Notice dx is 3 times du. So you have to multiply this with 3 du. It almost looks like ln of u, except we have this 3, but 3 is a constant, so you can pull 3 outside, and you will be left with natural log of u du. And then we can just use this formula. So this is 3 times u -1 plus ln of u plus c. And then change it back to x because we started with the variable x. So this is 3 and u is x over 3. The -1 plus natural log of x over 3 and plus c. And simplify, 3 and 1/3 will cancel and you will be left with x times -1 plus natural log of x over 3 plus c. Okay, so this completes the first part of the problem. Now we have to solve the same integral but using integration by parts. Now recall that in integration by parts we have to rewrite our expression in terms of u and dv. Now how do we choose our u and dv? First, notice that we just have one function, natural log. There isn't any other function. So what should we do with that function? Should we differentiate it? Should we integrate it? Now notice we can't really integrate it because that's what we're trying to do. We're trying to integrate. So we should not choose natural log as our dv, but we should choose natural log to be u because you can differentiate natural log. So where is dv? Well, the rest is dv, which is dx. So let's write this down. So you have u is natural log of x over 3. And from there you have to compute du, remember. So what is du? So you have to take the derivative of the right hand side. Now you have to apply chain rule because you have natural log and you have an expression x over 3. So outer function is natural log and its derivative is 1 over whatever that expression is, which is x over 3. And then you have to take the derivative of the inner function, x over 3, whose derivative is 1/3. So if you simplify, see this is just 1 over x, and then you also have dx. So du is 1 over x dx. Okay. Next, dv is just dx. So what is v? So if you integrate dx, what do you get? You get x. All right, so now we have all four, u, du, v, and dv. So let's apply integration by parts. And recall that if you have an integral of the form u times dv, by parts is equal to uv minus integral v times du. And now we rewrite all these expressions here. So u is natural log of x over 3. Okay. V is x, so this times x, minus, inside the integral, you have v, which is x, and du is right here, 1 over x dx. All right. So you have x ln of x over 3 minus, inside the integral, x and 1 over x cancels, and you are left with dx. Next, let's integrate dx, and that is just x. And then you add the constant of integration. So this is the solution using integration by parts. Now, since we are evaluating the same integral, it should give us the same result in part A and part B. Are they same? Okay, let's see. See, in part A, we have a common factor of x, and in part B, we see both these terms have common factor of x. So let's factor x, and then we'll be left with, see, from the second factor, you have the second expression has a -1, and the first expression will be plus natural log of x over 3. And that looks like exactly the one we got in part A. So we have the same antiderivative using both ways, integration table and integration by parts of this particular function, integral of natural log of x over 3. Thank you.